Now we'll discuss about heat dissipated in a resistance. We know in a circuit, if through a resistance R a current I flows, and if the terminals of the resistances are, we know that VA minus VB, the potential difference across resistance, can be written as IR according to Ohm's law, or this IR is the potential drop across this resistance R. Now in this situation we can say if a charge Q is passed through the resistance, then work required in passing this charge will be, we know that work required in transporting a charge from one point to another, we can directly write that it will be charge multiplied by the potential difference VA minus VB. So this can be written as QIR, joule. This much amount of work is required in supplying from point A to B through the resistance R. And this amount of work will be dissipated in form of heat from the resistance, because when the charge is passed, it will undergo several collisions in the resistance, the material of resistance, and that is dissipated as heat according to Joule heating effect. Now in this situation, if I is the current flowing, we know that per unit time I coulombs are passed through R. This implies we can write work done in maintaining the current I in R is, and we can write work done in maintaining the current in R per unit time is, this per unit time work can be written as power, which can be written as, here we can substitute I instead of Q. So this can be written as I multiplied by IR. This is the amount of work required per unit time, because if the current I is flowing, the charge supplied per unit time is I. That will be I square R joule per second, or I square R watt. This is the amount of work which is being done by some external source or EMF source or any agent who is responsible for maintaining this current I. And this much amount of work will be dissipated in form of heat according to Joule heating effect. So this power equals to I square R. We can write as thermal power dissipated in resistance. And using this thermal power, we can easily calculate the total amount of heat produced in a given time depending on the value of current in the circuit. Let's continue on the next sheet. As we have just now discussed that the amount of thermal power produced in a resistance can be written as I square R, this measured in watt. And here, depending on the value of current, we can easily calculate, like if I is constant, that means if a constant current is flowing through a resistance, then total heat produced or heat dissipated in resistance R in time t equals to 0 to t equals to T is given as, this can be calculated as H is equals to I square R multiplied by T, that is I square RT is measured in joule. Because I square R amount of heat is being produced per unit time, so in time t it can be directly written as I square RT. But in a situation if I is given as a function of time, it is not a constant, then total heat produced in R from t equals to 0 to t equals to t is, this can be given as h is integration of I square r dt, which is integrated from 0 to t. You must be careful about it, or it can directly be written as integration of thermal power dt, because thermal power is the power produced per unit time. So in time dt, the power produced will be p dt, which can be integrated from 0 to t. So be careful that if a constant current is flowing, we use I square RT, and if a time varying current is flowing, we use p dt or I square R dt integral from 0 to t. This is the way in which we can calculate the total amount of heat in joule produced in a given resistance.